Hello students, Mr. Williams here. I wanted to take a few minutes to talk to you about models as we get ready to watch the solar system scale model video. So, to astronomers and other scientists, making a model has a specific meaning. Taking into account our knowledge of the laws of science, we construct a mental picture of how something works. We then use this mental model to predict the behavior of the system in the future. If our observations of the real thing and our predictions from our model match, then we have some evidence that our model is a good one. If our observations of the real thing contradict the predictions of our model, then it teaches us that we need to revise our picture to better explain our observations. In many cases, the model is simply an idea. That is, there is no physical representation of it, nothing to hold. So, if when I use the word model, you picture in your head a scale copy like 1 to 200 of a battleship or some Lego model of the Millennium Falcon from Star Wars that you put together as a younger kid, this is not what I mean here. However, that doesn't prevent us from making a physical representation of the model. So, for example, if you are studying tornadoes, you could build a simulated tornado tube using two 2-liter soda bottles filled with water. However, for it to be useful as a scientific model, you would want to use the physical model to try and study aspects of real tornadoes. In modern science, many models are computational in nature. That means they're done mathematically. That is, you can write a program that simulates the behavior of a real object or phenomenon. And if the predictions of your computer model match your observations of the real thing, it is a good computer model. A really excellent example of that would be when we predict hurricanes. And these, what they call the spaghetti models and the cone of error for prediction, those are all computer models that predict the paths of those storms. So this is also a good time to introduce a statement referred to as Occam's razor, or the law of parsimony. So this is a simple statement that, paraphrased, in other words, putting it in my own words, says if there are two competing models to explain a phenomenon, the simplest model is the one most likely to be correct. Think of it this way. If you propose a model and you go about explaining it, and you have to make some special circumstance that you can't explain in evidence, we'll call that, I'm invoking the Easter Bunny. And if you have to do that more than once, then your model is probably wrong and needs some adjustment. So as you look at today's video, tell me, was it a good model? What was great about it? What did it not show? Could you improve upon it? Go watch the video, do the work, and have a great day.